proceed to stoichiometry. So how can we address and find the limiting and excess reactant by applying stoichiometry? So these are the rules and strategy. This is easy. I just simplified a lot of technique into six rules, I think. Okay, 6 steps. First is to balance the equation. It is always the first rule. If you didn't balance the chemical equation, then the rest of your answer will be wrong. So always check if the chemical equation is balanced. Um, Second step, you have to convert the given amount, which is in the problem, and then you have to convert it into moles. So we will learn it later. Then, third step is use the mole ratio. So this mole ratio is from the balanced equation. So if you have a wrong balanced chemical equation, therefore, your mole ratio will also be wrong. And then this is used to calculate the number of moles product form. And then from what we learned a while ago, that limiting reactant has a smaller amount of product, and then the excess reactant will have a bigger amount of product than the limiting reactant. And the last one is to find the theoretical yield, which is also our limiting reactant. So it is really important to know which is the limiting and which is the excess reactant for us to find the theoretical field. So yield. So the theoretical yield class is the same with our limiting reactant, and the actual yield is given or done in the laboratory. So if you will pursue biology, chemistry, so you will have a lot of experimentation about this, and you will do the actual yield and experiment this type of chemical equation. So you will know why we have this percent yield. So for now, we will have, or we will know the definition of percent yield. So that is the success of your experimentation. Okay. So now let's go to our first step, which is to balance an equation. So it is really important to balance the equation. So let's go to our problem. So let's apply stoichiometry and in this problem. So let's read the problem. So we have 5 moles of N2 and 9 moles of hydrogen atom. So determine which of two reactant is the limiting reactant and how much excess is left over. So we will know also the excess left over. A while ago, we solved it. We know it, the excess tapioca pearl. That is the leftover reactant. And then we have here that um, given, okay, that its actual yield is 88.75 grams. So given the actual yield, and it is 88.75 grams. Okay, so first is always check if the chemical equation is balanced. Okay, so we have here class, when we combine the nitrogen and the hydrogen, we will have an ammonia. Okay, so some problem class, they don't have this chemical equation. So you have to do your chemical equation. So you have to really read the problem, okay? You have to understand and analyze the problem. Okay. For this example, it is already given, but is the chemical equation balanced? So let's check and learn the different parts of chemical equation. Okay. So this one class, and this one, okay, and this one are all the same. So this is our, or the number of atoms. So meaning, when we draw this nitrogen, we will have 2 nitrogen. So it is a diatomic molecule. So same as well with our hydrogen. We have hydrogen bonding. So this one is a covalent bond, the nitrogen. Number of atoms. So we have also 2 hydrogen. Then we have here nitrogen. Same here in our ammonia. We have also the number of atoms. But how about this one? We don't have subscript. So this one is called subscript class. So what if we don't have the subscript here? So if you don't have the subscript, meaning it is automatically 1. So you don't have to write number 1. It is just automatic. So when you don't see a subscript there, it means 1. Okay, there we go. So no subscript is equal to 1. So now that we have this, let's go and see the other parts of the chemical equation. Now, you can see some chemical equation we have. Okay, 2 or 3 here. For example, this is just an example. This is not balanced yet. Okay, so this one class is our this one is called coefficient. So it denotes the number of molecules or compound. Okay, so for example here class we have 2 nitrogen atoms, and because we have 2 coefficient here, meaning we have 2 molecules of 2 atoms of nitrogen, so we can write it as this. Okay, so this one is our 2 nitrogen. So how about here? We have here 3. So same as well. Okay. So we have this coefficient. So it denotes the number of molecules or compounds. So here we have molecules. So we will have 3 molecules of hydrogen atom. So 1, 2, 3. 2 and then 3. So this one class is our coefficient. So this is how you understand or see our chemical equation. So do you have any questions? If you don't have, please give me a thumbs up. Okay, there we go. So let's move to balancing the equation. Okay, so for this one class, okay, I will not set a rule. So if you watch a different YouTube video, so they have this type of balancing that they do. For example, reactant. Okay, so let's have an example. Okay, so for reactant, okay, so we have here nitrogen and hydrogen. And for our product, so they create a table. So N and H. For me class, this will not be effective if we have a lot of element in the chemical equation. So this one will be hard if we use this table. So let's apply it later and let's see why it is hard to apply this one. So for this case class, you have to practice and be familiar with the different coefficient. No, not the coefficient, but how this chemical balancing is done. Okay, so what we need to achieve here, that the product or the amount of atom in our reactant and in the product will be the same. So for each atom of an element. So for example, here we have our ammonia. It is our problem. So nitrogen, we know that we have 2 atoms from our reactant. Then here in our product, we only have 1. And in our hydrogen, we have 2 here, and then hydrogen, we have 3. As you observe, it is not equal because nitrogen and nitrogen here is not equal. 2 and 1 is not equal, as we know. And 2 and 3, it is not equal. Okay, so how do we make this equal? So let's see. And to make it equal, what multiplier will you add? So if you multiply it by 1, so same, it's still 2. But if you multiply it by 2, it will be 4. But how about this nitrogen in our product? So we cannot multiply it by itself kasi it will be 1. But 2 we can. We can multiply it by 2. So we will get a 2 atom of nitrogen. But how about, so now it is equal. Now, how about our hydrogen? So how will you make this equal? So think of a multiplier that when you multiply this, it will achieve the same answer, product. It's multiplication, so the same product. So here, when you see 2 and 3, you can think of a or an odd number. Multiplier, an odd number, and also a multiplier of even. So here we have 3. So always, class, think of the smaller or the smallest possible product that you can get. Okay? 2 times 3, that will be 6. And then 3 times 2, that will be 6. So now it is equal. So how can we apply this in our coefficient? Okay. So here, class, in our nitrogen, in our product, we have to add 2 coefficient because here, we know that our subscript here is 1 and here is 0. So when you multiply it, class, 1 times 0, 0, meaning it does not exist. But we have to put 1 and another coefficient of 2. As you observe, class, our nitrogen here, represented by the blue circle, it is now 2. Now let's go to our nitrogen. Same, you have to add 2 coefficient. 1 and, is it 2? Okay, so it is just 1. So as you can see, we have 1, 2, and then 1, 2 of nitrogen from our product and reactant. So now it is equal. But how about our hydrogen? So as you can see, class, in our product, it is 3 times 2, that is 6. And here, to make it 6 hydrogen atoms, so we need to multiply it by 3. So 1, 2, and 3. So therefore, it is equal. So in this case, class, this table is easy to apply. But if it, let's have an example of that later. So let's have another example. How about this one? So we have methane and oxygen. So we have a combustion. And then we have carbon dioxide and a water molecule. Okay. So let's put, as we know, we have coefficient 1, 1, and 1. Okay. Still, let's apply this one. We have C, H, and O. So this one is this reactant, the CH, which is the methane, and the oxygen. And we have here carbon dioxide and then the hydrogen. So as you can see, class, if we have this type of combination of atoms or elements, as you can see, we have oxygen here and we have oxygen here. So if we combine this one, okay, let's see. Okay, let's go to the reactant. So we have 1 carbon, 4 hydrogen, and then 2 oxygen. So here in our product, we also have 1 carbon. Our oxygen is 2 plus 1. So 2 plus 1, we have 3. And our hydrogen, we have 2. Okay, so this is a little bit tricky. Okay, so let's apply what we've done a while ago in balancing and see if we can easily apply it to this type of problem. Okay, so let's check the hydrogen because the carbon is already equal. So 3 and 4. So to make it equal, we need a multiplier or a product of 12. Say, if we reach 12, when we'll multiply it by 3, these hydrogen atoms will be 12 and this one will become also 12. So let's multiply it by 4 and this one by 3. So now we have 12 atoms of hydrogen and 12 atoms of hydrogen. Now it is equal. Oh, sorry. I'm so sorry. It is not. Okay. So this one is hydrogen. I'm so sorry, class. So this one is hydrogen and this one is oxygen. Okay. Sorry. So this one is our oxygen. Okay, so let's go back. So when you want to achieve the same product of each of the reactant and product, we have to multiply it by, or we have a product of 6. So that is the smallest possible product that we can have. So 2 times 3, that will be 6. And then 3 times 2, that will be 6. Okay. So now the oxygen is equal. Now let's go to the hydrogen. So 4 and 2. And to achieve this number, you can multiply it by 2. So 2 times 2, we have 4. So now our reactant and product of each element are already equal. So the number of atoms are now equal. Now let's apply this one. So here, class, our carbon is 1. That is correct. Carbon is 1 here. However, our oxygen will change. So how? As you can see, we have oxygen here and oxygen here. But here, we have only oxygen. So it will, the other element will not be affected. So let's add 3. So 1 and 3. So now we have 3 molecules of oxygen. Now let's go to our product. So how can we or make it equal? To have 6 oxygen. So you add 2 coefficient here. Okay. So to make it 4. And here to make it 2. So now we have 6 oxygen in our product and our reactant. But our carbon now is already 2. So therefore, class, okay, the one that we applied a while ago will not be the same in this type of reaction or chemical equation. Okay, so this table, okay, so for me, it is not efficient. So it will confuse you on how to balance an equation. So for this type, class, you can just trial and error, try, and until you achieve the same number of atoms. Okay, so let's do that. So let's see. So now we achieve that the oxygen is equal. Now our carbon is not equal. Therefore, we need to add another carbon here to make it equal to 2. So 2 times 1, that is 2. 1 and 2. But our hydrogen atoms now is equal to 8. So our hydrogen now is 8. And here we have only 4. So you need to add another element. Okay. So let's restart this one and we will not use this table. So for me, it is easy if we don't use this table. Okay. So it is not always applicable to this type of chemical equation. So let's try again. Okay, let's delete this one. Okay, so let's start again. Okay. So let's analyze the different atoms and the number of each atoms in the reactant and product. Okay, so we have 1 carbon, it is equal. But here, our oxygen is not equal. So therefore, we need to add it. And also our hydrogen. So let's add 2. So now our hydrogen is equal 4 and our hydrogen is equal to 4. Okay, now it is equal to 4. Then these 2 will be distributed in this oxygen. So now we have 2 atoms of oxygen because it is only 1 here. So we only have 2 atoms of oxygen. Now let's go to this part. Because 2 plus 2, we have oxygen of 4. Okay, so to make it equal here, we just need to add another molecule. So therefore, we have 4. So it is easy if you do it that way. You don't need to write the table because for me, so it is confusing. So I just try and error, look at the different element, its subscript, and its coefficient. So to make the chemical equation balance. So it is up to you if you want to use the table. Okay. So but for me, you cannot apply with the different equation like this one. So any question, class, in chemical balancing or balancing of chemical equation? Okay, so let's try this one, class. So we have ammonia, oxygen, nitrogen, and water. As you can see, we have oxygen here and oxygen here, but this oxygen has hydrogen. And here we have hydrogen with the nitrogen. So this type of reaction is simple replacement. Okay, so we know a simple single replacement reaction. And then let's look at the subscript. So let's put 1, as we know it is always 1. Okay, there we go. So look at the number of nitrogen. We have 1 here because it has 1 subscript, and we have 2 here. So to make it equal, we have to add another 2 here. But why not here? We just add 2 because when we add another 2 here, another 1 molecule, then we need to increase this one. So we will just add this part. So now that we have 2 nitrogen, it is equal. Now let's look at the hydrogen. So our hydrogen now is 6 because 3 times 2, that will be 6 hydrogen. And here we have 2. So to make it equal, we need to increase the number of compound. So we add another compound of water molecule. So we have 2 times 2, that will be 4, plus 2, that will be 6. So therefore, our hydrogen is now equal to 6. Now it is equal, but how about our oxygen? Is it already equal? So 1, 2, and then 1 and 2. So therefore, our chemical equation is, is it? Try again. Why? It is not balanced. Hydrogen, nitrogen, why? 4, sorry. This is not this is not hydrogen. Sorry, class. My vision is not clear. Okay. So this one is not hydrogen but nitrogen. So still we need to increase it by another. Ayun. There we go. So we have 6 hydrogen. And now let's look here. We have 3 atom. Okay. 3 atoms of oxygen. And here we have 2. So what will we do next? So we cannot add another molecule because this will make it what? So this one is even and this one is odd. So you have to add another oxygen molecules to make this equal. So we have now 2 times 2, we have 4 atoms, and here in our oxygen we have 4 atoms. So 1, 2, 3, 4, and our hydrogen is now 8. Okay, so now it is 8. our hydrogen is 8, and here our hydrogen is 6. So therefore, we need to increase it again. But if we increase it by 3, 3 times 3, that will be 9. So what will we do? Still, we need to add another coefficient to make the hydrogen equal. So let's add another 4, 3, and then it is 9. The hydrogen is 9, and then let's add another to make it even. So now we have 4 times 3, we have 12 hydrogen. Now we have 12 hydrogen. So this one, class, is really a trial and error. Okay. So now that we have hydrogen, which is 12, and here we have 8. So we need to add another 2 molecules of water. 1 and 2. So now it is equal. So our hydrogen now is equal. So 4 times 3, 12. And then 6 times 2 is 12. But how about our nitrogen? So our nitrogen here is already 2, but here it is 4. So we will just add another coefficient. So 2 times 2, that will be 4. And here we have nitrogen of 4. And now, how about our oxygen? So our oxygen here, class, is 6. So 6 times 1. So our oxygen is 6 atoms. And here we only have 4. So we will need to add a 1 molecule. So now it is equal. Okay. So this one, class, you really need to step up our game and do a trial and error. So it is okay if you are slow, but when you get the hang of it, it will be easy. Okay. So any question about the chemical equation? Balancing of chemical equation? Okay, so let's proceed.